Alrighty guys, so I'm making this video to show you the answers for the study guide. Let me preface this by saying that if you are watching this video only to copy down my answers to get the bonus credit for the study guide, um, that's not going to fly. It's not going to work. Okay? I'm only doing this so that you are supposed to check what you've already worked out against what they should be. If there's any issues, then you can fix them. Okay, this should not be just you copy down what I have so I can get bonus points. All right. Now, I'm going to try and explain things as I go. So obviously, if you need to pause it at different moments to do some work that I've started for you, that's fine. Feel free to pause this whenever you want. All right. Number one, judging by appearances, which one's a parallelogram? We have to remember the definition of a parallelogram, and it has two pairs of opposite parallel sides. So we have to look at each figure and see if we have two pairs of opposite parallel sides. So if we look at this one, by appearance, it looks like that pair is parallel. And it looks like that side's parallel. So it looks like it's choice A, but let's check. This isn't, because this side and this side are eventually going to meet, and so are the other two. So that's actually a trapezoid. Now, it's not even a trapezoid. Or not parallel, that's just some random quadrilateral. This looks like a trapezoid to me because you have one pair. Remember, a parallelogram has to have two. And then this is a this is a hexagon, so that's not even a quadrilateral. So it's choice A. All right, number two. State the most specific name for the figure. So it looks like another parallelogram because it looks awfully similar to this one. But notice we have those tick marks all the way around. You should remember that those tick marks mean congruent. So we have all four sides are marked congruent. So this is actually a rhombus, because a rhombus is a parallelogram with four congruent sides. Number three, which is true. So for this one, you're going to have to think about that chart that I gave you a couple weeks ago, about like it started with quad and then it worked its way down through all the shapes, how they're related. You have to kind of use that. It's also kind of a thought-provoking question. You have to sit and think about it for a minute. So, is every rectangle in the world the same thing as a square? Well, let's think about it. A rectangle has four right angles, but all the sides are not the same. A square has four right angles, and it has all four sides the same length. So this one is not true. A square is a rectangle, but a rectangle is not always a square, so it's not that one. All squares are rectangles. So the way I kind of think about this is look at the second one, because that's kind of like what you're comparing to. And you have to see what the specifications are for this last one, because if the first item meets all the qualifications of the second item, then it's true. So is every square in the world a quadrilateral? So what's it take to be a quadrilateral? Four sides. So that seems right. Let's keep going just to make sure. All quadrilaterals are parallelograms. So what's it take to be a parallelogram? You have to have two sets of parallel sides. Does every quad have that? Nope. And then is every quad a square? Of course not, because a square is very, very, very specific and a quad isn't. So your answer here is B. All right. If the measure of angle B equals the measure of angle D equals 33, so that means both B and D are 33. So I'm going to go mark that. What is C? We want to find C so that we get a parallelogram. Okay. If this is going to be a parallelogram, notice that C is on the same side of the parallelogram as both D and B and D. Okay. We talked about that the same side angles are supplementary, meaning they add up to 180. So if I take 33 and whatever this is supposed to be, if I add those together, it should be 180. So what I'm going to do is 180, subtract 33, and the measure of angle C is supposed to be 147 degrees. All right. Angle 2 is 3x minus 26. Angle 4, 2x minus 11. They want angle 1, so this is what I'm looking for. I'm going to put a circle around it. Okay, notice what they gave me. So always look at what they gave you. They told you expressions for the opposite angles. And we know from earlier, when we learned in class, that a parallelogram has opposite angles are congruent, meaning they're the same. So what we have to do is set those equal to each other first. So let's do that. So this is number 5. So 3x minus 26 equals 2x minus 11. Set those equal and we'll solve it. So move the smaller x. Okay? But this doesn't answer the question. Remember, we're trying to find the measure of angle 1. Now that we know what x is, I'm going to plug it back into one of these expressions to get this actual angle measured first. So let's do that. I'm just going to pick 3x minus 26. 3 times 15 minus 26. What does that get me? Gets me 19 degrees. So that means that, angle 2, I found it to be 19 degrees. And like we said earlier, 1 and 2 are same side, which means they have to add up to 180. So to get 1 now, I'm going to do 180, subtract the 19 I just found. And so it's 161. Okay, that's a bit of a longer problem because there's a lot of steps involved. You have to set those equal to each other first, solve for x, plug your x back in. That's how we got 19. And then we used 180 minus 19 to get that. Okay. Now with this kind of problem, where they give you ON, LM, NM, and OL, those are the sides, so I like to label. So ON is 5x minus 4. LM is 4x plus 7. NM is x minus 7. And OL is 2y minus 6. Find the values of x and y. Right, notice now we have the sides are given to us. So if we want to be a parallelogram, what has to be true about the sides? The opposite sides have to be congruent. So this side has to be the same length as this side. And this side has to be the same length as this side. So in other words, we're going to set these equal to each other. So let's do that. Five x minus 4 equals 4x plus 7. Then the other pair, x minus 7 equals now, which one can I solve first? I can't solve this because I don't know x, nor I don't know y. So I'm going to come over here and find x first. So we'll subtract the smaller x. All right, now I come over here. I found x. So I'm going to plug it in. There we go. So we found x to be 11 and y to be 5. Alrighty. What can you use to conclude that the quadrilateral x, y, z, w is a parallelogram? So what I would do is draw each case that you have here, draw it up here on your figure and see if that's enough. And if it's not, we'll erase it and do another one. All right. YZ, so YZ is congruent to XW, and WZ is congruent to ZY. Oh, ZY, I've already marked it. Well, I may have to put another one there. Is that enough? Nope, because I only know the sides that have to be congruent have to be opposite each other, so it's not that one. This is really what I do. I do each case and compare, and if it's not right, I erase it and go to the next one. Let's look. ZN is congruent to NW, and XN is congruent to NY. Is that enough? The answer is no, because we're trying to say, wait, no, it's not right. I thought it was for a minute, but it's not. If the diagonals, this is trying to get you to think the diagonals are bisecting each other. In other words, they're cutting each other in half. But what that would mean is the diagonal from W to Y, each piece of it would have to be the same length. So whatever this side is has to be the same as this. And it's not. And the same for the diagonal XZ. Each piece is not the same length. So it's not letter B. So let's erase. YZ is congruent to ZW, and and WZ XY. Same choice as letter A, just different parts. That's not enough. So hopefully D is the one that works. So let's double check. YZ is congruent to XW, and WZ is congruent to XY. Is that enough? Yes, it is, because it shows that both pairs of opposite sides are congruent to each other. That's what you have to make sure of, okay? I told you to skip 8, so we're not going to do it. Based on what we're given, number 9, can you prove it's a parallelogram? So what do we know? I see the diagonals are drawn in, and I see that each piece of the diagonal is concurrent to the other piece. So, in other words, I can see that the diagonals are bisected, so we're going to say, yes, the diagonals bisect each other. Okay, number 10, same question, but different information. So what do we know? I see this pair of sides is marked congruent, and they're opposite, and the same with this. They're congruent. So I can visually see that the opposite sides are congruent. So yes, both pairs of opposite sides are congruent. All right, number 11. Which reason can be used to conclude that LMNO is a parallelogram? And hopefully you can see it on yours, but I noticed that one pair of opposite sides is both parallel and congruent. And we talked about this on our third lesson for this unit. It's the last theorem. It's kind of strange. It's the only one that works like this. But there is one pair of opposite sides that is both parallel and congruent. Oops, fix it where you can see it. There we go. So that is enough to say that that is a parallelogram. If you have one pair of sides that's opposite, one pair of opposite sides, I think it's key that it's opposite. One pair of opposite sides that is both parallel and congruent. That's enough to say it's a parallelogram. All right, number 12. It's a rhombus. So remember, rhombi have two special properties, both involving their diagonals. One of them says that right here where your diagonals meet, so I'm going to actually draw the diagonals in so you can see them. Hopefully you can see them on your paper. Okay. Where the diagonals intersect right here, everybody is 90 degrees right there. It says the diagonals are perpendicular. So all those intersections are at 90 degrees. Okay. Property number 2 says that when the diagonals come and meet these opposite angles right here, it cuts them in half. So in other words, this piece and this piece marked number 3, and this one marked 70 are the same, all the same. And so using that actual theorem, if this piece down here is 70, then every other piece that I've marked with the little arc is 70. So the measure of angle 3 is 70 degrees. And I got that because diagonals bisect opposite angles. All right. Keep going. We have another rhombus. What is the measure of angle 3? So I'm going to look right here. I'm looking for angle 3. So I'm going to use multiple theorems right here at once, all right? It's a rhombus, so I know that every side is the same. I know that angle 1 is 90. And then I also know that all these other ones are 90, so if I wanted to mark them all. So every angle right here is 90. And then I noticed that on this diagonal right here, I know this little piece is 25 degrees. Well, from what I just said on the last problem, diagonals of a rhombus bisect opposite angles. So if this little piece is 25, this other piece also has to be 25. Okay, so if I let me pull out what we're looking at right here. We know we have a right angle and a 25 right here, and this is angle 3. I have one triangle, and I know 2 angles. I need to find the third one. So I'm going to do 180, subtract 90, subtract 25, and that should give you 65 degrees. That's how you do that problem. Okay, another rhombus. They gave us expressions for all 3 of the angles. We want to find the value of each variable. So notice that all 3 angles are at the intersection of the diagonals. So every one of them is supposed to be 90. So first thing I'm going to do is every one of these, right? Every one of these is going to equal 90. So I'm going to set them all equal to 90. 9x equals 90. X plus y equals 90. And 3z equals 90. And we'll see if we can solve. Right here, we're good to go, so I can just divide 9. X equals 10. This one's also easy. I can just divide by 3. Oops. Z equals 30. Now the second one involves x and y, so I'm going to plug my x in. 10 plus y equals 90. I subtract 10. I can get that y is 80. So let's make sure we get all those. X is 10. This first one with x is 10 is y 80. Nope. So it's going to be D. Once you get all of these found, make sure you read each choice carefully and pick the correct letter choice, all right? All right, 15. For what value of x is xyza a rectangle? So notice that we're given expressions for part of the diagonal, of a whole diagonal. One piece of it is 7x minus 2, and the other piece is 5x plus 16. It's a rectangle, and the special property about a rectangle, other than all right angles, is that the diagonals are congruent. So they tell you that down here. M to B is the same as R to O. So whatever they tell you for these pieces, you're going to set them just equal to each other. So on 15, we're going to say 7x minus 2 equals 5x plus 16. And we'll subtract 5x. So we got x equals 9. All right. Number 16, we have a kite. So remember, a kite basically is like this. The two short sides are the same, and the two longer sides are the same. So I'm going to start with my short sides. We're going to set 3x minus 4 equal to x. I'm going to subtract the x. So I'm going to get 2x minus 4 equals 0. Now, I'm going to add the 4 because I need my number on the right side. And divide 2, we're going to get x equals 2. So we got x equals 2. Now the bottom two have a y in them. So we're going to set those equal. 2y minus 5 equals y plus 1. Minus y minus y. Y minus 5 equals 1. Add 5, y equals 6. We got y equals 6. All right, 17. Find the measure of angle 1 and the measure of angle 3 in the kite. I'll actually circle what we're talking about. So, kites are a little strange. They have a similarity to rhombuses in that all these intersections here in the middle are 90 degrees. So that's going to help us. And it's also true that when the diagonal comes up and hits the angle up here, it's going to cut it in half. So whatever this length is the same as this length. So if this piece is 18, the other piece is 18. So we're going to say the measure of angle 1 equals 18. Now we know this one's also 90. So I'm gonna pull out this triangle right here, just to show you something. We know this is 18. This is angle 3. We know two angles, we want the third one. So we'll do 180 minus 90 minus 18, which should be 72, if I'm right. Yep, 72. So the measure of angle 3 equals 72 degrees. Okay, we got another kite. How do I know that? It doesn't tell me a kite. Well, I'm looking at the markings. The two short sides are the same, the two long sides are the same, so we have a kite. We'll label what we know. They told us R was 110 and S was 90. They want T. Well, to do this, I need to find the third angle, angle U. Remember I told you when we did this lesson that the two angles that are like this, those two across from each other are always going to be the same. So if this one's 90, then angle U is also 90. And now, you should have learned in part A that if you have any kind of quad, does not matter what quad it is, all four angles add up to 360. So we're going to use 360, subtract the 110, and then subtract our two 90s. That will get us what we need. So 360 minus 110 minus 90 minus 90, we end up at 70 degrees. So the measure of angle T is 70 degrees. All right, put this back over. All right, 19. J and M are base angles of an isosceles trapezoid, so make sure you read that, that's important, of JKLM. So I'm going to actually draw me a trapezoid just for reference, and draw the isosceles one, so one like this, and that side is congruent to that side. We're going to go J, K, L, and M. So they told us J is 15x plus 7, and M is 13x plus 13. They want us to find K. All right, so we got a little bit to do here. K is up here. So first thing we need to do is find X. Because it's any trapezoid at all, whether it's isosceles or not, your base angles, which base angles are the ones that both touch the base, so J and M touch the bottom base, K and L touch the top one. And base angles are always congruent. So we're going to set our two base angles equal to each other. Move the 13x, so 2x plus 7 equals 13. Subtract 7, 2x equals 6. Divide 2, x is 3. Now, I'm trying to find angle K. So what's going to happen is we need to plug X back into one of these two. I'm going to put it back here in J. So 15 times 3 plus 7. Oops, 15 times 3 plus 7. So it's 52 degrees. All right. Now, how are we going to find angle K? Because it's an isosceles trapezoid, and only because it's an isosceles trapezoid are you allowed to do this. When you have isosceles trapezoid, the angles that are on the same side of the, right here, when I say same side like this, J and K are supplementary. It's the only time you can say it because it's isosceles. Okay? So if this one is 52, the measure of angle K is going to be 180 subtract 52, which is 128 degrees. So choice C. All right. Last problem. Find the values of A and B. What's this? What is this shape anyway? First of all, it is a trapezoid. How do I know that? Because I see these parallel arrows. Is it isosceles? If it were isosceles, I would have tick marks on my non-parallel sides. So this is not isosceles. And how are we going to find these angles? Well, let's look where they're at. Both angle A and 102 are touching this top base. And so we use the fact that base angles are congruent. So A has to be 102. And then this angle not marked 40 degrees and angle B, they touch the bottom base. So they have to be congruent. So B is going to be 40 degrees. All right, I just realized I made a mistake on number 20, so I need to fix it. And I apologize for that. Even I make mistakes. All right, I checked it up because I thought something was wrong that I did, and it was. So this is not an isosceles trapezoid. So it's only in isosceles trapezoids where the base angles are congruent, like we did on number 19. Okay? If it's a regular trapezoid, we can't say that the base angles are the same. They're not. Okay, they're not going to be. So how are we going to find it? Well, we have to use the definition of a trapezoid. We know that this side and this side are parallel. And so we have two sets of same side interior angles here. Okay, so in other words, angle A plus the 40, they're on the same side. So if I add those two up, I should get 180. So for angle A, we're going to do 180 subtract 40, which is 140 degrees. Similar for B. The 102 plus B is supposed to give me 180. So B is going to be 180 minus 102, which will be 78 degrees. All right, that's how you do that one. All right, that's the answers to your study guide. Again, make sure that you have tried everything that you can on the study guide before you watch this video. You should only be checking answers if you to see if you got it correct. It's not to copy mine down. As always, if you need help, let me know.